Hello everyone and welcome to another Resibuild Podcast, of Constructive Conversations. Today we're going to be joined by George from the FPA. We're going to be focusing on fire safety, a very topical theme at the moment, and the context and the title of today's podcast is Fire Safety Post-Grenfell, the progress, the blind spots and the industry challenges. Hello George, welcome and please introduce yourself.
Yeah, thank you very much for having me on. Yeah, I'm the technical director at the Fire Protection Association. Been working with them for about 10 years now, and most of my background's in fire research testing, and then a bit of consultancy before I moved into my director role.
Well, thank you, and glad to have you here talking about this major topic. So perhaps just setting the scene to start off with, we've obviously had the Building Safety Act, we've had the gateway processes and all that's been brought in relation to that and the Fire Safety Act. I guess the question for a lot of people is things moving quickly enough, or the government moving quickly enough? But I'd be interested to know, firstly, on your take of what's happened recently from a government point of view, and what your thoughts are around that.
Yeah, so we had the government response to the Grenfell inquiry. Yeah. A couple of weeks ago, and I think that was sort of well received widely. You know, they'd accepted all of the changes. I think there were 9 changes related to government that they wanted to work a bit more on, but overall they'd accepted most of them. Lots of them have sort of spawned off into other reviews, and so I think overall the sentiment, that's good, and it's great that they're all being actioned. But yeah, there are some comments around the sort of timescales, like you mentioned. We've post-Grenfell, we had the Dame Judith Hackett review. Then we've had the Grenfell inquiry, which went on for 7 years. That came out in 2024. Then we had a 6-month government review of those recommendations, and their review has recommended more reviews. So from an outside perspective, it can feel like it's taking a very long time. From the bits that I've been involved with, you can understand why they're taking so long, and it is important to get all of these things right. But in the meantime, there are a lot of things in limbo, whether that's fire testing, Gateway 2 applications, or cladding remediation programs that are sort of suffering from until all of this gets properly sorted out, how everyone would like to see it sorted.
So obviously with that, those kind of points you make there's been some good progress. There's the direction of travel. I think most people tend to be fairly comfortable with. There's obviously some nuances to that, like laminate glass, for example, we talked about earlier, and challenges for very specific and niche areas. But in terms of the human impact, we've got residents in blocks. There's obviously an impact for those which may still feel trapped by the whole crisis, if you like. Talk to us about that, George. What's your thoughts on the more social impact of that?
Yeah, I think there's a lot to unpack there. There's things that I've seen personally. I've got friends that are in those situations who are constantly asking me what's going on, what can be done. We've had people call up the FPA, just strangers calling up and asking about it. There was one period of time where we had people calling up in tears on a sort of daily basis about it, because they were trapped in these flats. They didn't know what to do. They were asking for help and guidance, but there wasn't much available. This was before we had all the cladding remediation programs in place. We're not getting those calls at the moment, but people are still stuck, and a lot of them, I think, sort of stuck with it. And on top of that, they're in a flat they can't sell, and the maintenance fees are going up. The insurance is really high, and it's not a nice situation for them, and they're sort of bearing the brunt of lots of other mistakes that have happened throughout. But we've seen a lot of changes happen there as well. So the residents, some ways looking for someone to blame. It's the person who's installed it, or the building owner, or the insurer. Why is it, or the government? Why is it taking so long? Why are we stuck there? And I think there was a period where lots of them sort of blaming the insurer, because those insurance fees are really high, and even in some cases where cladding had been remediated, the insurance stayed high, and that was because it had been remediated to life safety standards. And then none of the insurer requirements had been considered. So there was a building that would still spread fire around the building. It would still have a tolerable rate of fire spread, and that could mean fire spread per floor at a rate of 15 minutes per floor. Fire could break out into multiple floors, but that would be acceptable. under the remediation program and the goals of that, but wouldn't be acceptable from an insurer point of view. And that's where there was this big disconnect. And I think recently we've started seeing some residents come around and be not happy with the way the burn's been remediated. Start asking questions of, well, what is this insulation that you've put on? I want some more information about it. Is that still going to spread far? And I think there's a lot of work to do there. And I think the key thing is all the parties need to be involved early on, and that includes the insurer, contractors, and everything, so that a solution can come up with it that works for everyone. Because the government doesn't want to consider property protection requirements. They want to leave that to the free market, as it were. That's their only concern with life safety, make sure people get out. That's what they see as their responsibility. And protecting the property, make sure people got homes to go back to, that financially everything works. That's up to the free market. But the free market doesn't really work if the insurers aren't involved until right at the end. People don't get to consider, okay, if I go for a more expensive non-combustible material, what impacts that can have on my premium? Is that going to save me money in the long run? And that sort of thought process doesn't really get to happen if the insurers aren't involved till right at the very end.
Do you think that's happening more frequently now, that engagement with insurance companies and so on, than it was perhaps roll the clock back when we were seeing sort of 2018-19 time, we were seeing articles, as a few of those I can remember quite clearly, where insurance companies were kind of making blanket statements about MMC being banned for fire safety and various kind of bold things which might have been well received by the industry because they're saying, hang on a second, we're improving this. But do you think that perspective and the engagement is improving now, and therefore that's why we're not seeing so many of those kind of controversial areas?
Yeah, and I think changes on both sides. I think people are involved insurers early on, particularly with new build construction. They're aware of the role that they play in the whole process. And then the other way around, the FPA, we do a lot of research for the insurers, and we've had in the past 10 years a sort of change of way of working around that. Previously there was lots of scenarios of sort of working with wood, some modern methods of construction, where it's like, okay, that's not fire safe, don't do that, stick to non-combustible. And we've tried to change that narrative around, so it's like, okay, if you are going to work with wood, here's some ways to make it safe. Here's some ways you can do that in a fire safe way, and try and help people find solutions rather than just be seen as a blocker to cheaper, more sustainable construction. And ultimately that seems to be the way we need to go forward, but we need to do it in a fire safe way.
Yeah. So do you think the direction of travel currently is the right direction as far as it comes to fire safety, and the engagement with the right parties?
Yes, yeah, I think so. And I think the Grenfell inquiry recommendations, lots of them, will be great across the industry. The competence ones, I think are key. I think that's something the industry has been lacking for a long time. If we compare it to civil engineering and the competency that civil engineers require, or even just your sort of gas safety engineer who comes around and does your boiler, the level of competency he has, has a much better audit trail than fire engineers have in the past. So we're seeing great changes there, and in particular changes to fire engineers, fire risk assessors, and the certificate for installers. I think is going to be a huge change, and it's not just about making sure that they are competent. It's also having that audit record, so when you go and hire someone, you've got someone, and there's some extra information about them that can be verified by a third party, and it just helps the whole process.
Yeah. So clearly, the lack of proof of competency and so on in the industry. So the web of blame and the parts which will come through from the Grenfell inquiry will have eroded confidence from the public, will have eroded confidence from people within the industry, but insurance are particularly concerned with the risk. And that's no doubt knocked confidence in insurance. But can you tell us anything about that? Do you think that's being rebuilt? Do you think there's confidence in the individuals and the process and materials, or where do you think there might be gaps around that?
Well, yeah, and I think it will take a long time for everyone to get confidence back, and particularly the residents. It's going to take a long time to rebuild that, and there's a lot of steps need to happen. Like I said, that does impact on on insurance. We don't get a huge oversight of how much insurers charge. And part of the reason is because we do work for all of them. We're not actually allowed to ask for competition law and things. But from some case studies that I've seen, if buildings are remediated to property protection standards, we've seen premiums come back to similar levels to how they were before Grenfell, but still a little bit higher. And if it's combustible construction and one that promotes rapid fire spread, then very high premiums. And I think some of that was, cladding was a bit of a blind spot for insurers before Grenfell, and so and I think that's sort of the same across the industry. It was a bit of a blind spot, so I think people had too much faith in it, and so we may never get back to the same levels of faith, because I think there was too much faith that it was all fine, and I don't think that's sort of a healthy mindset.
Yeah.
Anyway, but I think it will take a long time. I think the competency, the enforcement, is a big one, and we're still not seeing enforcement in all the areas that we'd like to. The fire safety order came out a couple of years ago, October 2021, and that mandated things like residents have to see, or are allowed to see, all of the major risks and the risk assessment that will affect them. And get access to more information, and we're just not seeing that happen. We're seeing residents request it, not get it, and there's a law there that is really difficult to get enforced, and that sort of applies across. And I think those things are getting better, but until people start to see that, and they have a huge backlog of information of seeing that, it's going to be 5, 10, 20 years of hard work to get the faith back in the industry.
Yeah. And the more that transparency is there with the information, the more access there is to information is going to improve people's confidence.
Yeah.
And to move away from a scepticism around, for example, fire testing was something which came out in the Grenfell inquiry, which has been, there was a lot of information there which was known but wasn't shared, whether intentionally or not. That's one of the roles of the inquiry. But moving into that kind of limelight on fire testing, and there's lots of companies spending lots of money on doing it. We're certainly one of those as well. But do you think there's a need for more sort of tested values and so on generally, and to understand what's happening as an industry across the board, so we can actually learn more from all the testing people are doing? Because there is a lot of good work around that area. I know you guys do a lot of testing yourselves.
Yeah, and I think the fire testing is one example of that lack of faith on new builds. We're seeing lots of new builds above 11 metres being built out of fully non-combustible construction. Very few people are using combustible construction on new builds because, and I think some of that is around the lack of faith in the fire test methods, and not just the lack of faith in the method and the criteria, but also what's going to happen in the future. Is that going to change? Is that really going to prove that my system is safe and allowed? So we're seeing it impact on that, and some of that comes down to the sort of background and the way fire testing has been made in the past. A lot of fire tests have their roots 50, 60, 70 years ago, and very few fire tests are sort of just made from scratch with scientific principles, and this is what's needed.
So talk a bit more about that, the kind of background to sort of testing of those, because that's a long time ago when you look at modern methods of construction and fire performance in buildings now versus back then.
Well, yeah, so if we talk about cladding, for example, originally it just said that the outside of the building had to sort of resist fire spread and be of non-combustible construction, but there was no defined standard for non-combustible. So then some testing came in, and that was small-scale testing. We got the BS 476 series, parts 6 and 7, which are very controversial. And people realised that this small-scale testing didn't quite match up to large-scale. And that's when some large-scale testing happened, and that was around the 60s, I think, when that's how sort of BRE sort of led a lot of that research. And that cemented a lot of the foundations for what went forward. So things like the 15-minute criteria per floor, so that's the rate of fire spread that's allowed from one floor to the next during the fire test. That comes from some very old testing, which I think is 1960s, and has been sort of misinterpreted and extrapolated, and we see that across the industry. So what they were looking at was how fast could we expect fire to spread on the outside of a building, and so they did series of tests, lots of different constructions, and actually most constructions didn't spread fire from one floor to the other. So most non-combustible constructions they tested didn't actually spread fire from one floor to the other. So this is going out the window, coming out the facade, and going back in. And there were two notable that did. One of them took 30 minutes, and one of them took 17 minutes, but it was actually with combustible materials that were on there, and it didn't actually spread in 17 minutes. They had to end the test early for other reasons, and they deemed that it would have spread fire after the 17-minute mark. So that was just someone's judgment. The outcome of that was they then said, okay, so we can reasonably expect that fire will not spread from floor to floor within 15 minutes on the outside of a building. So that's what they decided based on that. Then, fast forward to 1990s and 2000, when BS-841 was being developed, the fire test for external cladding systems, they decided that, okay, because fire already spreads at a rate of 15 minutes per floor, that's what we'll allow for cladding systems. We'll say, okay, any cladding system, that's allowed to spread fire rate of 15 minutes per floor, because that's well established, so that's the rate of fire spread per floor. But when you go back and look at it, actually, that isn't the rate of fire spread per floor. From the testing, it was 17 minutes, and that was for a combustible system, and it didn't even spread in 17 minutes. Another one was 30 minutes, and most of them didn't spread fire from floor to floor. So that the fundamental principle of 15 minutes per floor wasn't really based on reality. Yeah, we see that across the industry. I think a much better and simpler example is people talk about the fire evacuation times for buildings and how that's linked back to the time it takes to sing the national anthem. Because there was a fire in the theatre in the 1800s, and it was reported that everyone evacuated the building before the national anthem had finished playing. So as they were evacuating, the orchestra started playing the national anthem, as they did back in the day. And it was reported that everyone evacuated before the anthem was finished, and that sort of became the initial thing for evacuation time. So yeah, not all of the areas of the fire industry have a scientific backing. Yeah. We have all these rules and equations that spawn off of that. They then go into fire models, and we do advanced fire modelling. But if you trace it all back to the root equation, the root decision making behind that, it's not always a fully scientific basis.
Yeah, and even if it was, I know one which was talking with a fire brigade chief a few years back, was saying about the 18-metre rule came from the length of ladders on the standard engines back then. And yes, it might have been based on logic, but things change over time, and it's the kind of the knowledge of how those principles are doing it. But there are other in this sectors, if you like, or other disciplines which are actually using standard data. Carbon is one. You've got carbon databases which are shared across the world. You've got structural engineering, and I know this is an area which you've got an expertise in. I'd be interested to know what your thoughts are on building up these shareable numbers and principles you can actually apply, which are based on physics and not just, as you say, extrapolating one thing to another.
Yes, one of the recommendations of the inquiry was a material database, and gathering that for all generic construction materials, having information on the fire performance. And the University of Queensland in Australia has sort of made a good start on a sort of groundworks for that, that we could use as a template.
Yeah.
The FBA ourselves, we've done some testing, yeah, I think you sort of covered it off really. What that will then enable, if all that information is there, is for someone designing a building, for someone learning about building design, learning about fire safety. You can have those core materials. They can go into a model or just a simple computer program for just looking at how you can combine things and how they might perform on the large scale. And you've got that information there to mix and match and then do computational analysis on it. And that is, what we have in the engineering world. If you go onto a computer-aided design program and you've got finite element analysis, which enables you to model, stress and strain and how something's going to perform under load, you can do that with lots of different materials, lots of different alloys of steel. That information is all there, and we haven't got that in the fire industry.
Yeah.
And although a product, one insulation product might differ from another slightly, if you've got the core materials phenolic and you've got the core data on that, you're able to do some initial calculations that can certainly help a lot with design.
Yeah.
And so I just want to say, because I think overall, what would be really nice is if buildings could be designed in a more holistic way.
Yeah, so it's important these things are considered holistically, isn't it? With if we take the concept of structural engineering, you've got what the weights are of products in, say, roof tiles, and you know what the bearing capacity is going to be for a steel frame down to the capacity of the ground to resist it as well. That can all be worked out. And that directionally would be a brilliant thing for fire engineers to be able to be engineering judgments we hear of recent regularly, for that to be based on much more recognised numbers and so on is great. Of course, these things can't be considered in isolation within that discipline itself. You need to take the structural engineering, thermal performance, you need to take the fire safety, and all those life safety pieces with the building performance need to be considered in a overall way, don't they? So I think I'd be interested in your thoughts on what we can learn from that Australian example you mentioned as well. What are the key things which we could take from that and apply in the UK?
So we've taken some at the FBA and done some work at the University of Central Lancashire. Our work was based on when we were doing cladding testing. We wanted to take a sample of the materials we were testing and be able to produce a material fingerprint of that. So we had a slightly different background. And that was because of some of the accusations in the Grenfell inquiry that manufacturers were testing a different material to what they were putting on the building, maybe a more fire retardant material. So we wanted to develop a method that could basically record what we were testing and create a chemical fingerprint for that. And one of the things that we used for that was MCC, microscale combustion calorimetry, which is something that's used in the aviation industry. And that's a test we've been very keen on. I think produces extremely useful data. Basically, it produces calorimetry data, so that is your general heat of combustion, so the total energy that will come out in a fire. And that's similar to what we get through regulations at the moment, through the bomb calorimeter test. But it can also test things in a slightly different way that better models how a flame works. And basically it'll pyrolyze a sample in nitrogen, so without oxygen. And pyrolyzing basically means it will decombust the sample down into its combustible products. They'll then be there in gas form, and it will carry those up to a separate chamber where it will introduce oxygen and set fire to them. And that much better models the environment we see in flaming combustion, particularly large-scale flaming combustion, where there can be no oxygen at all, where the pyrolyzing happens, where the thermal decomposition is occurring. And the outcome of that is, it then allows us to see the impact of things like fire retardants, which won't show up when you test the total energy of the product. So I think there's a good basis there. There's lots of tests they've done in Australia and different material properties that have come through. And I think, the next step is narrowing it down to what do we need, and then going out and testing as many products as possible. And building up a big database.
So it sounds like there's been some great work already done, and it'd be brilliant to learn from that piece, wouldn't it, in this country, but also learn from other industries, as you say, learning from aviation and so on, which we can look at and see much more advancement in some areas in construction. So the material selection and specification, what is used on building is one thing. The second piece of that, which is equally as important, is the competency and the individuals which are making those decisions. And that's obviously a focus point of the Hacker Review. It's also been a focus point in the Building Safety Act. And demonstrating that competency of those involved, both with the duty holder responsibilities, but also the other designers and so on involved in the project, that needs to be shown at Gateway 2 and demonstrated. But could you elaborate from your point of view on what you feel makes that meaningful, not a tick box exercise?
Yeah, so we talk a lot about composite, the FPA, and we join a few composite panels. I think, the key point is that it's not just about having the training. And we've talked in the past about the 3 pillars of competence. So you need to have training, you need to have experience, and you need to have recency. So on top of the training, you need to have actually done the work and been out there and exposed to it, and gain experience. And then recency, it's not just about being, I've done it recently, it's about being concurrent, doing CPD, being up to date and aware of the latest regulations. But we're seeing a lot of industry now talk about SCEB, which is skills, knowledge, experience and behaviours. And behaviours is an absolutely key one. People need to be acting in the right way. But the point of all of those different acronyms or systems is that, it's not just about training, it's not just about tick box exercise. You need to have evidence that you've done the work at a certain level, and you need to be up to date to be able to say, that person is competent and sign them off. And linking to Gateway 2, I think that's done a really good job of sort of forcing this through the industry. And I think some of the applications that haven't gone through is because people have just treated it as a tick box exercise, as that's just what we need, but and actually they need to demonstrate a bit more than just, this person's had the training, what projects have they worked on, how long have they been doing it, and that sort of thing. And then that's, at the moment, how to best demonstrate competency.
So we've heard the BSR, and we've regularly talk about not demonstrating competency and the lack of detail being some of the key drivers. Some statistics are received overnight from the BSR tell us that we've got 1,879 schemes which have been applied for in Gateway 2 process, but only 12 new build ones which come through, some of those being hospitals, some being residential buildings. But there's obviously a massive part of the process which has gone from a huge number to a very, very tiny percentage which have actually come through, less than 1%. There is obviously multiple facets to that, and it's not something we're going to be able to unpack in the rest of this podcast. But one of the things in there is definitely that approach, how people are approaching competency. Any tips you'd suggest people look at a Gateway 2 application demonstrating their competency from the working groups and from the knowledge you've got around that area?
I don't think there's any tips I could offer. We don't apply for Gateway 2. We're not subcontractors for anyone in a Gateway 2 application. I think you'd probably be better placed than me to answer that question. As I mentioned before, it is about more than just training. You need to demonstrate that you've got experience. If you're part of the Institute of Fire Engineers, for example, for fire engineering, then that's third-party, assessment of your competency. But it's about doing a lot more than just saying you've done the training and ping it in. And it does take a bit of effort to draw it all together for everyone involved throughout the process.
So I think what you mentioned about your 3 pillars, training, experience, and basically staying up to date, being the kind of 3 key criteria, if you like. Obviously, the behavioural pieces is one of the SCEB, which you mentioned, is all part of the Building Safety Act. It's written in law that needs demonstrating. But evidencing that is definitely a tip from our point of view, evidencing that you've got the relevant skills, knowledge, expertise, experience, behaviours to actually deliver on that particular scheme, and why that's relevant to that is certainly one of the key things which we'd suggest that people look at when they're talking to the different parties involved in their Gateway 2 application.
Yeah, and it's something I hope does get easy with time. Like I say, there are discussions around what needs to be done with fire engineers, fire risk assessors, and installers, and a certificate for installers. So, and those are all things, once they're in place and formalised, that will help with applications, surely, because there'll be more of a system in place, and it'll be easier to point to that and demonstrate your competence.
So, quick to ask question, difficult to answer, appreciate, but do you see any blind spots currently?
Yes, there's always going to be blind spots in regulations. I think a couple key ones. One of them is smoke toxicity. and this was touched on by the Grenfell inquiry, and it's a really difficult one to resolve. But yeah, we saw big issues with it in the Grenfell Tower fire tragically, and yeah, it does severely impact people's ability to escape. Particularly some of these fire retardant products, more plastics, PVC, in homes and in the building construction. Yeah, can produce a lot of toxic fumes that mean that people pass out before they get a chance to escape. And I think that's something that's not touched on at all in the regulations. There is a review of the furniture regulations going on at the moment, and there's a proposal coming out from that to improve the toxicity of furniture. But the outcome of that, I think that they're going to go with is that manufacturers just must consider the use of toxic chemicals. As part of the process, they have to consider it, and there's going to be a hierarchy of toxic chemicals to help them look at that and reduce the ones that they're using. And there'll be some labelling requirements so that it's more aware for the public. But overall, there's no strict requirement that says you cannot use toxic product. If you can justify it and say, well, there aren't any financially viable alternatives, then you'll be allowed to carry on and things. So in some ways, it's a shame that they haven't found a better way of going about it. But I think there's still a framework there that can be used across the industry.
I was just going to say, it's good to hear that. I wasn't aware that was happening from a furniture point of view, but if you take a building, or if you take a balcony fundamentally has to be non-combustible.
Yeah.
However, the furnishings which go on it, pretty much all combustible, and the activities which happen on it are what fundamentally make a big difference to the way that fires will, if they do occur, and how they will spread on that will be significantly changed by the furnishings. It's good to hear that there's some kind of element of consideration for the post-Grenfell world on that basis.
And balcony furniture was a topic, particularly on a set of flats and you've got balcony furniture. Is that classed as indoor or outdoor furniture? And should it, these regulations are for indoor furniture, so yeah, do they apply for that, or what happens there? But yeah, and particularly cladding systems, intumescence, things like that, I think all areas need to be addressed. But there's another big blind spot in the regulations, I think, is resilience. And this is something that insurers are very keen on. But what I mean by resilience is the resilience of the fire safety design of the building, if one component fails. So if you've got a fire compartment and part of that fails, what does that mean? And in traditional steel concrete construction, if a fire compartment fails, fire will spread into the next fire compartment. But if that one's built well, then it'll be contained within there. So happy days. But with modern methods of construction, with more wood involved, lightweight steel construction, they can be a lot more susceptible to a compartment failing, to fire spreading into those voids. Lightweight steel can collapse, or timber, devastating consequences if it gets into a void and there's a smouldering fire and it's in an area where the fire service can't get to. That can result in a total loss of the building. Mm-hmm. And we've done fire tests at our lab, and there's been fire tests at the other labs with timber. Famously, the Cardington fires at BRE in the early 2000s. I think one of the earliest examples of us knowing about these huge timber construction issues. But even in the fire tests, where we're just testing a compartment or a small sample, and we might have fire service on site to help with it, we're still struggling to put the fires out in these timber constructions. So when it's all built up in a building and they haven't got the access that we've got at the lab, it's difficult to think the fire service has a chance of putting them out. And so I think resilience is another blind spot in the regulations. The way we're designing buildings, we're becoming more and more reliant on things like cavity barriers, which previously were sort of nice to haves, and now it's a fundamental, important part of the system, otherwise it's going to fail. And those are things that are often installed wrong, installed badly. And so, it's sort of scary to see, even when people come for fire testing at the lab, we see cavity barriers installed wrong. So, and assuming you're sending your best guys for the fire test to improve your chance of passing. So what's happening on the buildings? And we know from lots of risk assessments, cavity barriers are often not, pretty much all of the time, there's a cavity barrier not installed correctly somewhere. So as systems become more and more reliant on these, I think there's a bigger risk to the building, to both life safety and property protection.
So in terms of making buildings more resilient, simple tips is reducing the number of penetrations, especially interfaces with these cavity barriers. That's a complex detail. The fewer you have, the more resilient it will naturally be, or should be. Any other small tips?
Yeah, and it's things like that. We talk a lot about sprinklers. Obviously a sprinkler system massively increases the resilience of the building. Having non-combustible zones. For example, if you've got a cladding system, you can have non-combustible zones between floors. So not just fire break, but a fully non-combustible zone. Enhanced protection in certain areas, enhanced fire resistance. In areas where you're worried about resilience. So yeah, it's about considering it and putting methods in place to reduce the overall impact. We do have lots of guidance available for it. We've got BDM 01, which is for design of buildings, and links to our sort of insurer version of approved document B, which talks a lot about sort of more resilient methods. I think sprinklers is for us, I think, the key thing for timber. We're very worried about these smouldering fires in timber construction. In the US, they have a lot of timber construction, and they use a lot of sprinklers in almost all of their timber buildings. And for us, we think that needs to be the key over here, because it's sort of the only system we've seen work. But there's problems with implementing that. At the moment, you're not allowed to install sprinklers in a combustible ceiling. So if you've got a mass timber CLT ceiling, you're not allowed to install a sprinkler system in the UK. And
why is that?
So the rules don't allow combustible ceilings because they don't want the pipework to fall down, and the sprinklers aren't prepared for fire spread across the ceiling. They're not prepared to put that out. So we've been doing research at the FBA into that, hoping to be able to release it soon. But yeah, basically looking at different fixings into timber, making sure that the screws are long enough so that if that ceiling is on fire, the sprinkler pipework's still going to stay in place. And then also look at the surface wetting on the ceiling as well, and appropriate designs of sprinkler head for that. So that's an area, and I think a good example where the FBA is not being a blocker, and we've said, okay, here's a way, currently you're not allowed to put sprinklers on your timber ceiling. Here's a way that you can do it safely.
Yeah, interesting. So in terms of being more resilient, one of your points here is kind of about reducing the reliance on the workmanship of the passive fire protection, but you're also suggesting that more active fire protection is needed as well, are you?
Yeah. In some scenarios, obviously, it can be expensive solutions, so not always appropriate, but it's about having multiple layers of protection is the thing. So yeah, and that can be multiple layers of passive protection as well. But it's just being prepared for any single compartment to fail, and that not result in a catastrophe. That's what resilience is all about.
Yeah. So in terms of the industry moving forward and directionally, how should it approach the change? What do you think the most critical areas of improvement for fire safety are at the moment?
I think, net zero is a huge thing in construction. I think both net zero and fire safety are the two biggest issues. And I think, addressing all of the net zero solutions and finding fire safe solutions for them is absolutely key. Because sadly, almost everything that's good for the environment is bad for fire, whether that's timber construction, whether that's a living green wall on the outside of your building, whether that's lithium-ion batteries. Lithium-ion battery storage, which tend to be key to solar panels or just electric vehicles, electric parking. But they present a unique fire hazard, and I think research basically is the key to finding fire safe ways of implementing them. Because in the absence of research, we see sometimes things just don't go ahead and initiatives stop, and other times we see people just sort of plough on. Green walls is one example where there wasn't any appropriate fire tests for them. one set of testing, the 13501 series. There's 4 tests you're meant to do for a cladding system. Green walls weren't appropriate for 3 of them, so they would only test to 1 of them, and they weren't really appropriate for that one, so they'd sort of not do the conditioning period as well, and just sort of do their own version of the test and do that and go on a building. And I think that's one of the scary things, is that industry does just plough on if we don't provide a safe solution for them.
So some interesting points you're making here, but I'd quite like to wrap up with asking you for a recommendation on kind of a key takeaway for the audience. What's your key takeaway, George?
Yeah, I think the key takeaway for me, and when we started this talking about the government's response to the Grenfell inquiry recommendations, is for everybody to take on board the Grenfell inquiry recommendations where it affects their sector. There's lots of good points there, and the very key one being around fire testing, having a golden thread of evidence and competency. And I think those are the key things to take forward for everyone.
So from my point of view, been interesting to talk about the various aspects of this overall. I think to make sure that we're not dependent on the skill of workmanship and making it much more data-led or science-led, if you like, I think is a critical part of that role. And in doing so, looking at some of these simple quick wins, if you like, of actually simplifying the details, reducing the number of interfaces and the working together of those, I think is a key part as a takeaway from my point of view. But George, thank you very much for joining us today. And to the audience, thank you for joining us too. As we can see, there is progress. There's a lot of lack of clarity and lack of progress being seen in some areas, but there's also lots of good work happening in the industry. And whilst we wrap up this podcast session today, we'd like to thank you for joining us, and we look forward to seeing you on the next one. Goodbye from us.